So our today's lecture is on dependent source. We'll learn what is dependent source and how they works, and moreover we'll try to solve different maths which includes dependent sources. So let's first come to the point. What is dependent source? I guess you already know that these symbols means sources, right? And this is a voltage source, and this one is a current source, right? If I put a value of 5 volt here and say 2 ampere here, it means this voltage source will generate a voltage equivalent to 5 volt, and the current will actually depend on the load, right? And that's why this is called voltage source, because it generates a fixed voltage. And this one is a current source, and the voltage across this current source will depend again on the load. Since it produces a fixed amount of current, that's why we call it a current source. So this is my current source, and this one is my voltage source. So now, as you can see that this voltage source or the current source has the capability of generating a fixed amount of voltage, right? Or current. But dependent sources are a bit different. The dependent sources are generally depicted by this diamond-shaped symbol. If I write something like this, this will mean a dependent voltage source, and this will mean a dependent current source. This is dependent voltage source, and this one is my dependent current source. Now, this voltage source or the current source, which is dependent, they actually don't have their own property. They don't have any own property or own characteristics. It means their voltage and current, the value of the voltage or the value of the current, is dependent on others. For example, the voltage of this dependent source may be dependent on the voltage of another resistor or maybe of another source. That means its value is not itself dependent only on this device. Rather, this voltage is depending on others. I will give some example later, but for now just remember that the value of this voltage source will not be its own property. Rather, it will depend on some other elements. By elements, I mean sources or different components like resistors, inductors, or capacitor, etc. So actually these are basic circuitry components, as you know already. So the value of this voltage source or the value of this current source will not be decided by its own. Rather, it will depend on others. Now, let's take an example. We will try to relate this example by some practical case. Let's say there is someone who is willing to buy say some gift that costs say taka 100. Okay, now let's say there is another person who actually have no idea what he gonna buy or what will be the cost of the gift that he will buy. So let's say this person is now relying on this person. So sometimes we talk like this, that if that person buys something at taka 100, I will buy something which will be 5 times expensive than his gift. That times, if he buys a gift for taka 100, that person will buy a gift for 5 times of 100. That means which will cost taka 500. If this person decides to buy a gift which costs, say, taka 200, now this person will then consider buying a gift which will be 5 times of 200, right? Which means taka 1000. So as you can see that this person is deciding what he gonna buy and what will be the cost of the gift. That means this person is not depending on others. He is making his own decision. This type of devices that we previously dealt with is called independent sources. And we depicted this like previously as voltage source or like the current sources. And this person here is an example of our dependent source. That means he or she has the capability of buying the gift, but he cannot decide by himself what will be the cost of the gift. Rather, it depends on another person who first decides what is the cost of the gift, and based on that, this person then buys the gift. For example, here we had a multiplier of 5, and this is the example of a dependent source that we depict as the diamond shaped symbols. Voltage source, dependent, or dependent current source. So in short, this type of sources, the value of this type of sources will depend on others. It may depend on some other independent source. It may depend on a resistor or a capacitor or some properties of inductor, etc., etc. It will depend on others. That's the main fact. So there's pretty much basic. Now let's say I have a circuit like this. There is a resistor, or say let's say there are 2 resistors, and let's say I have another circuit where there is another voltage source and there is a resistor. Now let's say we want to before going further, we just put some random values. Say this is 10 volt. Let's say this is 2 ohm resistor, and let it be some 6 ohm resistor. Okay, and say this is a 5 ohm resistor, and the value across this resistor, let us call this V, and the voltage of this dependent source, as we have already discussed, that it will not have any fixed value like this. Say this has 10 volt, right? But this device will not have any fixed value like this. Rather, it will depend on some others. Let's say in this circuit, the voltage of this source depends on this. Let's call it V1. And the voltage of this dependent source let's say this is 5 times of V1. It's like our previous example where a person buys something and another person buys 5 times of something. That something is now the voltage of voltage across the 6 ohm resistor. That means whatever will be the voltage of voltage across of the 6 ohm resistor will get multiplied by 5 and will decide what will be the voltage of this dependent source. So let's assume that we are required to find the current in this circuit. What will be the value of I? We know that in order to find the current, we actually need a couple of things, like V equals to the main Ohm's formula is V equals to IR. So if we want to find the value of I, then it will become V divided by R, right? Where V is the value of this voltage source and R is actually the resistance. So if I put the value of the voltage source, or actually the value across this resistor is the 5V1, right? And the value of the resistance here is 5 ohm. Now, as you can see that there is still one unknown. Which one is the V1? And how we can find the V1? We can find the V1 by solving V1 in this circuit. We know that V1 is actually a voltage divider because there are 2 resistors and the voltage is divided among those resistors. The current will be same, but the voltage will be different. If we apply the voltage divider rule as we learned in our classes, V1 will be 6 ohm will be on the top because we are finding the voltage across 6 ohm resistance, and it will be divided by 6 plus 2, that means sum of the 2 resistors times the input voltage in this branch, which is my 10 volt. So it will become 60 over 8. So we can write it as 15 over 2, that means 7.5. Now, if we come here, now as you can see that we have already sorted out the value of V1, right? Since now we have the value of V1, so now we know what will be the voltage of this dependent source. That is actually 5 times of V1. So if we called the voltage of the dependent source as VD, we can find the value of VD, that is 5 times of V1. So if we put the value like this, we will get the value of this dependent source. So it will be maybe something like 37.5 volt. So now I know the value of VD. That means I now know the value of this dependent source. So that's how the voltage of a dependent source is decided by other elements. So in future, you may actually know how these devices are being controlled. In most of the cases, current sources are developed using MOSFETs nowadays. So you'll learn it in your later cases where you will learn some electronics and others. But for now, we'll just focus on solving this type of problems. So as you can see that this device, by looking at this device or by looking at the parameter at first, we actually couldn't depict what will be the value of this dependent voltage source. Rather, we had to solve this circuit where we got the value of V1 and the voltage of this source is actually dependent on V1. This is how the dependent source actually works. So now let's complete the math where we were required to find the value of I. So if I just put the value of V1 here, that means 7.5, or I could have used 37.5 altogether here, divided by 5, that will give me 7.5 ampere. So the current So the current through this resistance will be 7.5 ampere. So the summary is that the properties of the dependent sources are like this. They don't have their own property. Like this example, this dependent source didn't have its own voltage, right? Rather, they will depend on others parameters, right? In this case, the voltage of this source was dependent on the voltage of this resistance. This is how they are linked. And since we have mentioned a word called depend, so and I have told you that it depends on others parameters, so now we have to understand what are the other parameters. By the word parameters, I actually mean two things. One is voltage, another is current. That means it will actually depend on others voltage or others current. For example, in this case, the voltage of this dependent source was dependent on the voltage of this resistance. In some cases, the voltage of this dependent source may be dependent on some currents. That means their value may be dependent on voltage or may be dependent on current. That's why we have several types of dependent sources. So we'll now discuss about the types of dependent sources. If you categorize them as we did previously, we have two basic types of dependent sources. Which one is dependent current source and another one is dependent voltage source. So these are the two basic categories for dependent sources. Now, depending on which parameters they are dependent on, we can classify them in again two classes. For example, the value of this current source may be dependent on others voltage or it may be dependent on others current. Similarly, the value of this voltage source, as we previously have seen that the value of the voltage source can be dependent on others voltage. For example, in this case, the value of this dependent source was dependent on the voltage of the resistors, which is 6 ohm resistor, right? Or this may be dependent on others current. That means in each criteria, we have two more additional criteria, which makes it 2 times 2 is equals 4 types of dependent sources. So to list all of them, we can have voltage controlled voltage source, which we may call VCVS, voltage controlled voltage source. That means this type of dependent sources are actually voltage source, but they will depend on the voltage of others. Similarly, we can have current controlled voltage source, which we may call CCVS. So they are again voltage sources, but their value will be dependent on others' current. That's why it's called current controlled, and this one is called voltage control, and they both are voltage sources. And we will draw a symbol like this for them. And if this is a voltage controlled voltage source, then its value may be say x times of some another voltage. And if this one is CCVS, then it's again voltage source, but its value may be dependent on others current, say y times of I1. So these values x and y is some parameters, or we may also call them as gains, which actually decides what will be the multiplier value, or how many times more or less the value of this source will be compared to this V1 or compared to this I1, right? So if we go further, now we can have voltage controlled current source. So as you can see that now this is a current source. We can write it as VCCS, and there can be another type, that is current controlled current source, or you can call them as CCCS. So as you can see that there are a total of 4 types. Voltage controlled voltage source, which is actually voltage source but depending on another voltage. This one is CCVS. This is again voltage source but depending on another's current. Now here comes voltage controlled current source. That means now this is actually current source, but its value is dependent on others voltage. So we may draw them like this: a current source, dependent current source, and the value of this dependent current source is now depending on others voltage. And similarly for CCCS, it's again current source, so we'll draw like this, and now this will be dependent on others current. So this is the full summary of the types of dependent sources. So there are actually total of 4 types of dependent sources: voltage controlled voltage source, current controlled voltage source, voltage controlled current source, and current controlled current source. The first 2 is actually voltage source, dependent voltage source, and the last 2 are actually dependent current source. So these are the types of different dependent sources that you will encounter in different circuits. Now you may wonder, how can I solve a circuit consisting of dependent source? Okay. If we want to answer this question, that means if we're thinking that there may be some new formulas or maybe some new rules, I would like to tell you that there is actually no new rules to solve this type of circuits. So you should be happy to know that we will actually use our previous learning experiences, such as solving a circuit by Ohm's law, or maybe solving a circuit like KVL, KCL. All of the previous things that we learn in our classes can be applied to solve a circuit which has dependent source. So it means we can use our previously learned techniques to solve them. So you don't need to panic because it's very easy. There will be just a couple of lines extra in case of this dependent source related circuits and maths. But it won't be something difficult, or it won't be something new, or you will not be required to apply any new technique, or you will not be required to apply any type of new formula to solve this type of circuits. So you should be happy that you have already learned all the basic rules. There is Ohm's rule, law, KVL, KCL, Kirchhoff voltage law, Kirchhoff current law. You have already learned this type of things, and we have already covered these things in our meet. So I guess you are now already quite acquainted. With all of these rules. So now today I will actually demonstrate a circuit which is based on KCL. Now let's take a look at a very basic KCL example for dependent sources. Let's use just one dependent source to start with. Because if we start with a very complex problem, we may not we may end up not understanding the system. So rather we will just start with something easy. Okay, so this is going to be a very easy math for you, and we will apply our previous idea regarding KCL to solve the following circuit. I'll draw the circuit on the left and just try to solve it on my right. So I may not complete the math with the numeric values. You may proceed to put the numeric values and solve the rest of the things. Rather, I will actually go towards the procedure. That means how you will solve the math. So let's take an example which should be very familiar to you. So I guess you may already know the circuit, and a similar circuit was solved in your class. Let's say now this circuit has one dependent source, and this be our ground. Say this has a voltage of 10 volt. We have to find the value of, say, VA, the voltage of this terminal. There's the value of this resistance is 10 ohm. This be 5 ohm, and let's say the value of this resistance is 3 ohm, and this one is 2 ohm. And now let's consider that this is a current controlled voltage source. That means this is a CCVS, current controlled voltage source. That means its value is its voltage will be dependent on current. It's a voltage source still, but its value will be dependent on current. Let's indicate a current here and call it I, and say this one has a value of 8I. Remember, this is still a voltage source. By just watching here at 8I, don't consider that this is a current source, because in most of the cases we have used I for currents, right? But here, remember, this is still a voltage source, just its value is numerically, only numerically dependent on current. Okay, so this is still a voltage source. I am just repeating it again and again, so that you don't get confused in your exams by just seeing this oh my god, this is a current source and how can I solve this circuit. No, this is still a voltage source, just the value of this voltage source is dependent on current numerically. So it still has the unit of volt, not ampere, and it still is a voltage source, and we will treat it like a voltage source that we, and now we will treat this one as the voltage source that we used previously, like this one. Okay, now if we want to solve this problem, then we have to use our basic KCL method. In this circuit, we actually assume that all the currents are either outgoing or all the currents are incoming. So let's consider that there are three currents, which one is I1 and I2 and say I3. And as I already solved different problems in the classes, we actually write this one as the primitive form of the KCL, and then we can write like I1 plus I2 plus I3 at this node. That means sum of all the currents at this node should be equals to 0. So this is the starting point for any KCL math, and I guess you already know that. So now let's put the value of I1, I2 and I3. So if I just put the value of I1, the starting of I1 is from VA and the ending of I1 is at 10 volt, and there are two resistance in series in between them, which is 2 and 3, which makes it 5 ohm. So we can write I1 as VA minus 10 divided by 5. So the starting terminal voltage is VA, any terminal voltage is 10 volt, and the voltage and the resistance in between these 2 points is not 3 or not 2. It's actually the summation of 3 plus 2. I guess you already know that. I2 has a starting point of VA, and I2 here is ending in the ground, and we know that the ground has a voltage of 0, and it will be divided by 5 again. So plus there is another one which starts from VA, and now it ends in a dependent source. But since this is the voltage source, we don't need to worry, because the value of this voltage source is already known, is 8I. So the ending voltage here is 8I divided by the resistance in between them is 10 ohm equals 0. That means we have used our previously learned KCL here, KCL technique here, and starting from the primitive format of KCL, we have went through the formula where we actually encountered all the voltages. Now if there was only one unknown here, so I will just put out all the units, because you don't need to use the units here. So if we could convert this equation into a single variable equation, then it will be very easy for us to solve. But as you can see that there are actually a total of 2 variables here. One is VA, and there is another variable here is I. So in order to solve a 2 variable problem, we will need at least 2 equations, and after you have 2 equations, you can use substitution method or any other technique to solve this to solve this equation. So we now have to focus how we can get the value of I. If we look at the circuit, the value of I can be related, because the value of I, as you can see, is the current through this branch, and the direction of this current is clockwise. If we actually look here, there is another current which is I1. This I1 is also the current of this branch. That means the value of I and the value of I1 should be equal. Why? Because they are the same current of same branch, except they have different arrow. That means one is opposite to another one. That's why we can write I as minus I1. I guess you will all agree with me, because Numerically, they will have the same value because they are the current of the same branch. But in case of direction, I1 is going clockwise. Sorry, I is going clockwise and I1 is going actually anti-clockwise. That's why they have opposite direction and we have to use a negative symbol here. So now if we want to find the value of I, we can simply just put the value of I1. And how we can find the value of I1 is pretty simple. I1 has a starting point of VA and ending point at 10, and the resistance in between them is 3 plus 2 is equals to 5. So you can just write VA minus 10 divided by 5 to get the value of I. Now we can simplify this by putting the negative inside. So it will become 10 minus VA divided by 5. And now I have the value of I. So I can just put the value of I in this equation, or you may use any other technique by solving it by calculators or other ways. But I would just like to substitute the value of I in our previous equation number 1. So let us call this equation number 2. So now the new equation will become VA minus 10 divided by 5 plus VA divided by 5 plus VA minus 8 times I. And we know that the value of I is 10 minus VA by 5. So we can write 8 into 10 minus VA divided by 5 instead of I divided by 10. Now we can solve it like this: VA by 5 plus VA by 5 plus, if we just LCM, do some math here, we'll get a total of 50 below, and it will be 5 VA minus 80, and it will be plus more 8 VA equals to 0. So now we can write VA minus 10 divided by 5 plus V by 5 plus there were 5 VA already and more 8 VA is there, so it becomes 13 VA minus 80 divided by 50 is equals to 0. And I guess you already know how to solve the rest of the thing. If you just forgot, I would like to remind you like this. The first term here is 1 by 5, the second term is also 1 by 5, the third term should be 13 divided by 50 is equals to, you can write 10 by 5, then there is nothing here, so there will be a 0, there is negative, so it will become positive 80 over 50. Now you just put the value of all of these things and you will find the value of VA from this equation. So now let's sum all the things all together. First, we actually went through a very easy example. I am calling it easy because you have already encountered similar type of maths in your class. So this is a as I have mentioned, that KCL based example. So we will try to find the value of some voltage in the circuit. Here we were required to find the value of VA. So this math was pretty simple except from this dependent source. The problem here was we had one dependent source that was related to I, and the I was related to the current of this branch. So how will you solve this problem? Number one step, we have to write the KCL equation. Then step number 2, we had to find each of the current values such as I1, I2, I3. So how we can find the value of I1? We can find the value of I1 by like checking the starting point and ending point. We know that if we want to find the current, we have to write like this: starting point voltage minus ending point voltage divided by resistance. So I mean I1 will become VA minus 10 divided by 3 plus 2 is equals to 5. This is my I1. I2 will be VA minus 0 divided by 5, and I3 gonna be VA minus 8I divided by 10. So this is my equation number 1. We could have solved this equation, but there was a problem that there was one additional unknown here, which is my I, and we have to find the value of I. By looking the circuit, we actually saw that I was equal to I1 because they are the same current of the same branch, but the direction of I and I1 was opposite. That's why we have wrote here I equals to minus I1, and we can find the value of I1 very easily by choosing the starting point voltage, which is VA, and the ending point voltage is 10V divided by 3 plus 2 is equals to 5. So it becomes 10 minus VA divided by 5, and then we will substitute the value of I into this equation. So everything will be as previous, except we will substitute the value of I. Instead of I, we will write 10 minus VA divided by 5 that we got here. Okay. Then we just did some LCM based things, and these are basic mathematics. Finally, we can find the value of VA by just taking VA as common from this equation, and all the numeric value just put them on the right side, and at last you can just put all of these values in your calculator. That means 10 by 5 plus 80 by 50 divided by 1 by 5 plus 1 by 5 plus 13 by 50. Just put it on your calculator and you will find the value of VA. So this is how we can solve a problem that actually incorporates a dependent source. So in our next lecture, we will actually see some more detailed example that may have several voltage source or may have several current source, and we'll see how we can solve those. And again, don't panic. This is just as simple as we did with our KCL math. And that's all for today. So if you have any problem with anything, just let me know. And the course plan or the list of maths that you can practice, you can find it in your Google Classroom. So thanks everyone.